For this chapter, chapter 7, I really wanted to go over Pearson correlation coefficients with you because they are complicated and time consuming, although the math in itself really isn't that hard. You just have to make sure that you do each step and do it correctly and be able to figure it out, okay? So this is a section in the book that says 7-6A. Since we don't have any page numbers, it's hard for me to point you to an exact page number, but this should take you to the formula that you need. Now, in the book, when it starts off as 7-6, it originally gives you a correlation coefficient that talks about R equaling the sum of z squared x's times d squared y's over n. That is essentially what you're doing, but this formula breaks it down so that it's more it's more manageable. It's something that you can actually do without having to find the z-score of each number and then adding them all up. Okay, so it's trying to make it a little easier for you. So now let's talk about the Pearson correlation coefficients a little bit. And this is what R is, okay? What is R? It means that you're trying to figure out how well two things are correlated. And you can correlate pretty much anything. And the example in this particular portion of the book is correlating the number of cups of juice you drink in a day to the amount of times you have to see a doctor in a year. Okay, so the hypothesis is the more juice you drink, the less you'll have to see a doctor. Okay, so they're trying to see if there's a correlation between juice and doctor visits. And the R is always essentially a percentage point. Okay, so it would be something like this. In a book, you would see, okay, we did a regression analysis. We got R equals 0.89. And what that would mean is that doctor visits can be explained 89% by the number of juice that you drink, or the amount of juice that you drink. But this is considered a pretty strong correlation. If you think in terms of percent, it gets a B, almost an A. If it were like a 0.60, that would be a D, and so forth and so on. And then if we see a negative correlation, so a positive correlation means as something goes up, something else goes up, okay? One of the examples that I have in the research class is as the more you weigh, usually the taller you are, okay? That would mean that both things are going up, weight and height, okay? If you have a negative correlation, that means as one thing goes up, one thing would go down. So in this case, if you're thinking in terms of juice, the more juice you drink, the less doctor visits, and that makes it a negative correlation, okay? That's all that a negative means when you see an R. So let's go back to this equation. We have to break it down, okay? We have to, it's easier if we take it in bits and pieces. So we do this first, and then we do this, and then we do this, and then we multiply these together, and we multiply n times this, okay? So you want to do it in pieces. Now, what you don't want to do is do it in pieces and then forget a step. So you want to make sure that you're doing each step. I highly recommend, and your book even gives you a chart, when you are doing this, you want to have a chart, okay? And you want to have, what your chart is of raw data. What does raw data mean? Well, okay, in here we have 4 participants, and I took this out of the book. It's right below this equation. So in the book, there's 10 people. I only did 4 because it's easier for the example. Okay, so I have 4 participants. For the first participant, I asked them, and here's my X raw data. I asked them, okay, how many cups of juice do you usually drink in a day? And they're like, 0. I like juice. Okay, and so then you said, all right, and here's your Y raw data. How many doctor visits did you have last year? And they went and looked in their calendar, because really, who remembers that kind of thing? And they said 8. You're like, okay, so my raw data for participant 8 is 0 and 8. Now, I realize there is a column in between these, but just ignore it for right now. Okay, so now we have participant 2. They said, I drink 0 things of juice each day. And I looked at my calendar, I have 7 visits to the doctor. Okay, third person said I drink 1 cup of juice a day, and I had 7 visits to the doctor. Fourth person said I have 1 cup of juice, and I went to the doctor 6 times. That's your raw data. Okay, so let's go back up here and just look at what's in these parentheses here. Okay, this weird little symbol means the sum of. So it doesn't mean that I just take the sum of the x's and multiply them by the sum of the y's. No. What this is telling you is you want each raw data of x multiplied each raw data of y, and then you add all of those up. So what does that mean? What it means is I'm going to take my first raw data, 0. I'm going to multiply it by 8, and look at that, I'm going to get a 0. Okay, way over here. Okay, there. So then I'm going to take my second person, and I have 0, and I'm going to multiply that by the 7 doctor visits they had, and again, I'm going to have 0, because 0 times 7 is 0. Third person, 1 times 7 is 7, 1 times 6 is 6, okay? Now I can add them up. 0 plus 0 is 0, plus 7 is 7, plus 6 is 13, okay? So now I know that the sum of my x times y is 13, okay? So, and I have 4 participants, right? And this is your n. Now in your book there's 10, so don't get confused when you look at the book, because these numbers are a little different in the book since they used all 10 people and I only used 4. So if you go back here, n, this one piece of it, n times the sum of x times y equals 4 people times our 13. Okay? So we did that. That's this piece. Now we want to do these pieces. So let's start with this one. What does that mean? The sum of the x's. This is the sum of the data points added up. So 0 plus 0 is 0, plus 1 is 1, plus 1 is 2. So we have 2. So this piece here is 2. Okay, so we can go back down here and we can plug it in. So 2. Now we need to get the sum of the y's. Okay, so the sum of the y's are these raw data points, right? We're just going to add them up. 8 plus 7 plus 7 plus 6, and that all equals 28. Trust me, use a calculator. Okay, so now we have to plug that in to our equation. So now we have the first part of the top and then the second part of the top, so we have 2 times 28. Well, we have to remember we can't just subtract this from this. First we have to multiply the pieces together. So 4 times 13 is going to be 52. 2 times 28 is going to be 56. 52 minus 56 equals -4. Okay, so for this is just our top part of the equation. All of this equals this. So we have our top, okay? So now let's go and tackle this bottom portion here. Now, one of the key things that people forget is to take the square root of the final number that you get, so I don't want you to forget that, but we have to break them apart. So first we have these are in brackets, right? So what that means is that this bracket is multiplied by this entire bracket, okay? But first we have to do the pieces in there. Again, we have n, which is the number of participants, times the sum of the x's squared. Now, this doesn't mean you just add up all the x's and then square them. This means we have to square each x first and then add it to the next one, okay? And that's this column here that I told you to just ignore for the moment, okay? So we have to take each raw data point and square it. Well, here it's easy. 0 squared is 0. 0 squared is 0 again. 1 squared is 1. 1 squared is also 1, okay? And if you add all these up, you get 2, okay? So this portion right here is now 2. So we can plug that into our little equation, and we have, where are we at? 2, okay? Which if you compare these, this is what this looks like. But I'll show it to you in a minute. Okay, so now let's do this one. Minus the sum of the x's and then squared. This is a little confusing. You don't want to get them mixed up. Okay, what this means is, yes, we're going to actually add up all of just the raw data, and then we're going to square them. Okay, so go back here. We have 0 plus 0 is 0, plus 1 is 1, plus 1 is 1, plus equals 2. Sorry, plus 1 equals 2. Okay, But now I'm going to square it, which is what this little 2 here is. Okay, so this second portion here is now 4, because 2 times 2 is 4. All right, so we go here, and then we plug it in. So this is now 2 minus 4. They're in brackets because I had this n here. I crossed it out because n equals the number of participants, and remember, you have 4 of them. Okay, so I'm going to put 4 there. So now this whole bracket is 4 times 2 minus 4. All right, that's the x's. Let's go do the y's. Okay, same deal, but we're going to do it with the y's. Number of participants times the sum of the y's squared. Okay, again, it's not the y's added up and then squared. It's each y squared and then added to the next. And again, that's this column, right? So I did 8 squared is 64. 7 squared is 49. 7 squared again is 49. 6 squared is 36. Okay, now I add these up. 64 plus 49 plus 49 plus 36 equals 198. Again, trust me, use a calculator. Okay, so now we know that this is going to be 198. Okay, now the next part, y's. And this is just the raw scores added up, and then we're going to square them. Okay, so that's just this column. 8 plus 7 plus 7 plus 6 equals 28. And now we have to square our 28. And that comes out to 784 because I plugged it in down here. Okay, so this is the first bracket that takes care of the x's. This is the second bracket that takes care of the y's. So now I have 4 times 198 minus 74. And 74 is our 28 squared. It's this number squared. Okay, so we have to do the things, the parentheses first, multiply them. So 4 times 2 is 8, and then we just bring our 4 down. So we have that, and then 8 minus 4 is 4. Same over here. We have 4 times 198 is 792 minus 784, and that's going to equal 8. Now we just multiply these two together. This is what was in this bracket, or what was in this bracket, okay? This is what was in this bracket, or what was in this bracket, okay? 4 times 8 is 32. We don't want to forget that we have to take the square root of that. And that is the number times itself that equals 565, okay? I'm sorry, the number times itself that will equal 32. And what we come up with is 5.657. Now remember, your book suggested that we go out to the third decimal place just so that we're as accurate as possible. Can you see that? That's a horrible 5. We'll make it prettier, okay? So now we're just going to do that. So now we plug it back into our equation. Let's go back to our equation. This is the entire equation. Now remember, we did this, okay, which was this section, and we got -4. And then we did this, okay, and we got this 5.657. So now we just plug it in. -4 over 5.657, okay, we go -4 divided by 5.657, we get -707. And we break that, and now we just need 2 data points, or 2 decimal places, so r equals -0.71. Okay, which means that this correlation is 71% strong. Our negative doesn't mean that it's bad. What it means is that as juice drinks go up, doctor visits come down. And what we would say is that we can, that doctor visits can be explained 71% by the amount of juice you drink, okay? And that this negative just means that as juice goes up, doctor visits go down, okay? So, obviously, if you have more data points, more answers to your X and Y, it takes a lot longer. That's why I only stuck with 4, okay? It's a lot of tedious math, but it's doable. You just have to make sure that you break them down. And you have to make sure exactly what the sum of is adding up, okay? So whatever this is, it's each data point added together. So that's Pearson correlation coefficient. If you have any questions, feel free to email me. If you want, you can always stop by on my office hours and I can go over the information with you.